Hello math students, today's video is lesson 4.3 dividing polynomials. In this video we are going to learn how to divide polynomials using two different methods. The first one is polynomial long division. Polynomial long division is very similar to the long division that we learned in elementary school with just numbers. So for example, if I wanted to take 172 and I want to divide it by 5. What I want to do is we want to say, well, how many times does 5 go into 17? 5 goes into 17 3 times. 3 times 5 is 15. And then we subtract. Gives me a 2. Bring down the 2. 5 goes into 22 4 times. 4 times 5 is 20. Subtract. Gives me a 2. This last number right here, we would say is the remainder. So a lot of times I would say that this is 34 remainder 2, or I can say this is 34 and 2/5, because I had 2 parts left over out of the 5 I was dividing by. So we're going to do a very similar process when I do polynomial divided by polynomial. So my top, what's on top is what goes inside of that little box. So I have x cubed minus 2x squared minus 37x plus 13. The number on the bottom goes on the outside. And just like what we did with numbers, I want to know how many times does x go into x cubed? Well, if I go x cubed and divide it by x, subtract the exponents, which gives me x squared. Like we did with numbers, I'm going to take x squared and I am going to multiply it by x minus 7. So I go x squared times x squared minus 7 gives me x cubed minus 7x squared, and then I subtract. X cubed minus x cubed is just 0. But I have to be really careful when I'm subtracting here, because it's not just the first number you subtract, it's everything that I need to subtract. So I need to go negative 2x squared minus negative 7. This is really adding 7, so this gives me a 5x squared. And then I'm going to bring down this negative 37x, and we repeat the process. I want to know how many times does x go into 5x squared? Well, 5x squared divided by x is 5x. So I'm going to say plus 5x, and then I'm going to multiply 5x by x minus 7. Gives me a 5x squared minus 35x, and then I subtract. 5x squared cancels out. Negative 37 minus negative 35 is a negative 2x, and then bring down the 13. I need now to multiply, or I need to go negative 2x divided by x. The x's cancel out, leaving me with just a negative 2. So I take negative 2, multiply it by x minus 7, leaves me with negative 2x plus 14, and then I subtract. Negative 2 minus negative 2 is really negative 2 plus 2, which is 0. 13 minus 14 is a negative 1. Once I get to this point, x doesn't go into negative 1. So this last number right here is your remainder. And so just like we wrote it on the last one with the fraction, I'm going to put the end of my answer plus negative 1 over x minus 7. And that is my answer. I want to go over one more example of dividing using long division, and then I'm going to go and show you a kind of shortcut method to dividing polynomials. So this example, I have 2x cubed plus 7x squared minus 4x plus 7, all divided by x squared plus 2x minus 1. So x squared plus 2x minus 1 goes on the outside. 2x cubed plus 7x squared minus 4x plus 7 goes on the inside. I need to compare 2x cubed and x squared. Well, 2x cubed divided by x squared is 2x. I need to take 2x, multiply it by x squared plus 2x minus 1. That gives me 2x times x squared is 2x to the 3. 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. And then subtract. When we're doing long division, we always want to have the first term of our subtraction cancel out. If it doesn't cancel out, then we've done something wrong. So 2x cubed minus 2x cubed is 0. 7x squared minus 4x squared is 3x squared. Negative 4 minus negative 2 is negative 2x, and then I'm going to bring down the 7. So now I want to know how many times does x squared go into 3x squared. So 3x squared divided by x squared is just a 3. I'm going to take 3, multiply it by x squared plus 2x minus 1. 3 times x squared is 3x squared. 3 times 2x is 6x. 3 times negative 1 is negative 3. And then subtract. 3x squared cancels out. Negative 2 minus 6 is negative 8. 7 minus negative 3 is 10. If I compare my degrees on these two polynomials up here and down here, x squared is bigger than x. Once we reach this point, I am left with the remainder. So I'm going to put that on the end, say this is plus negative 8x plus 10 all over x squared plus 2x minus 1. And that's my answer. So polynomial long division really is not that difficult. It's nothing that we haven't done before. But the only downside is it does take up a lot of space. That's the only thing that I don't like about polynomial long division is just how much space it takes up. The bigger your degree, the more space it's going to take up on your paper. So we have what is called synthetic division. So we can use that, takes up less space. The only downside to synthetic division is you can only use when you're dividing by something in the form x minus a. So you have to have a coefficient of 1. Your degree has to be 1. And then you're either going to be adding or subtracting a number. So what I'm going to do when I am doing my synthetic division is I'm going to only work with the coefficients. We're not going to have any x's at all in our synthetic division. So I'm going to start by writing down all the coefficients that I have on the top of the fraction or in the first polynomial that I have that I'm dividing. I don't see a number written in front of x cubed, but there's really a 1 that's there. So I'm going to write down a 1, -2, -37, and 13. From the bottom, I'm going to just use this -7. But instead of having to always do subtraction and then remembering to subtract negatives and that gets really messy, I am going to change the sign. So I'm going to use a 7, and I'm just going to write it over here, just kind of out of the way, but in a space that we know where we can see it and use it. I want to make sure right here that I leave a row of space. Otherwise, it can get kind of messy. So I just want to make sure that I leave enough space that I can write a number in between my top row and the line. So every time I do synthetic division, the first thing I'm going to do is I'm going to take my first number, bring it straight down. No matter what that number is, drop it down. My next step is I'm going to take this 7 that I have up there, and I am going to multiply it by whatever number we just brought down. And I'm going to write my answer in the next column. So 7 times 1 is 7. And then I'm going to add these two numbers together. -2 plus 7 is 5. And then I repeat the process. 7 times 5 is 35. Add these two numbers together. -37 plus 35 is a -2. 7 times -2 is -14. 13 plus -14 is a -1. So now you're thinking, well, what do these numbers represent? This is really easy what we just did. It was just multiplication and addition. But what do they mean? If we go back and look at the first example that we did, we'll notice that it was the exact same problem we were doing. I had my answer was x to the 2 plus 5x minus 2 plus -1 over x minus 7. If we come back to the problem we just did, I have a 1, 5, -2, and -1. These are the exact same numbers. This 1 represented 1x squared. This 5 went with the 5x. That -2 was my constant term. And then this -1 at the end was the remainder. So this is my answer with the synthetic division. So when we write our answer, there's a few things we need to keep note of. So with your answer, it will always be 1 degree less than the original. So that means the biggest exponent on your original problem is going to be 1 more than the biggest exponent on your answer. And then the last number is your remainder. So let's go look at another example of doing synthetic division. One thing that we'll notice on this one is I don't have an n to the 1 term. I could rewrite this, though, as 7n to the 3 minus 42n to the 2 plus 0n minus 6 all over n minus 6. These are the exact same, except for on the second one, I put a 0n in as a placeholder for that n to the 1 term. This is something that you're going to always want to do when you're doing synthetic division. If there's a number that, or an exponent that's missing, put a 0 in its place. You don't necessarily have to rewrite all of this that I did on the right side, but just make sure you put the 0 in where it would go when I write the coefficients out. So now when I write my coefficients, I have a 7, a negative 42, 0, and negative 6. It was n minus 6, so I'm going to put a positive 6 over here. Always start by bringing down the 7. I'm going to go 6 times 7 is 42. Negative 42 plus 42 is 0. 6 times 0 is 0. 0 plus 0 is 0. 6 times 0 is 0. Negative 6 plus 0 is negative 6. So when I write my answer out, I started at n to the 3. So that means my answer is going to be 7n to the 2 plus 0n plus 0 with the remainder of negative 6. And so this is my answer. So now you're probably thinking, well, even though I put that 0 in there, there's just a bunch of zeros. Does it really make that big of a difference? Well, let's see what happens if I try to do it without putting that 0 in. So I bring down the 7. 6 times 7 is 42. Negative 42 plus 42 is 0. 6 times 0 is 0. Negative 6 plus 0 is negative 6. So I have a 7n to the 2, because I started with n to the 3, plus 0n. Well, this last number right here is supposed to be my remainder, but I don't have my constant term yet. So I don't have enough numbers on the bottom. So that's why it's so important that we put that 0 in. This one, it didn't make a huge difference, but there are problems where if you didn't put the 0 in, it would cause a lot of problems. So these are some examples of doing long division with polynomials and synthetic division with polynomials. And we'll do some more with these when we get into 4.4.